In section 10.3 today. So we talked on Friday about, we talked about parabolas, and we talked about what we meant by a conic section. How parabolas, if we sliced a cone parallel to one of the sides, we get a parabola. Well, an ellipse is another conic section. So let me grab a picture of this. So if we slice a cone and it goes through both sides of the cone at an angle, the shape we get is an ellipse. Ellipse is kind of like a stretched out circle. So if I slice this cone at an angle and it goes through both sides of the cone, I get an ellipse. So that's why we call the ellipse a conic section, because it's a piece of a cone. What we're going to do with the ellipse is similar to what we did with the parabola, and we can make some definitions about the ellipse based on its shape. So let me grab an ellipse here, and we will talk about the definition of an ellipse. And then we'll talk about the math that we're going to do with the ellipse. So here's our ellipse, looking at it face on. A couple of important pieces of the ellipse are the two, we call them foci. Foci is plural of focus. So we have an ellipse has two focuses, a foci. The definition of the ellipse is the set of all points where the distance let me see, where I'm going to say, rather than the distance, just to make it easier to say this, the sum of the distance this is an ellipse. The set of points where the sum of the distance from two foci is constant. So what that means is, if we take any point on our ellipse and I find the distance from the one focus, so this is our point xy, and I go to the other focus and I call this d1 for one distance and this d2. What this definition tells us is that d1 plus d2 is a constant anywhere on the ellipse. So anywhere I go on the ellipse, if I add the distance from the point to one focus to its distance from the other focus, I get a constant. So that's part of what makes ellipses special. And Mr. Lowe agrees. And what we're going to do is use this definition, and we're going to talk about A's and B's and C's, and be able to figure things out about this ellipse. But it starts with the ellipse being a conic section, and from that we can figure out these two distances, if we add them together, are constant. All right. So a couple of important points on an ellipse. So this is our definition. let's label some important points. So let me grab another copy of this. So important points on our ellipse. We have the two foci. This long segment here is called our major axis. And it's labeled the major axis here. The skinnier part of the circle is the minor axis. The point here where the two axes cross is the center. That's a tough one, right? The points at the end of the long axis, the major axis, are the vertices or vertex. And the points at the end of the shorter, the minor axis, are called the co-vertices. The length from the center to the major to the vertex, this distance here, not to the focus, the distance to the vertex, we call A. The distance from the center to the focus, we call C. And the distance from the center to the co-vertex, we call B. So we have on a parabola, we just had one thing that we had to keep track of. We had to keep track of P. On an ellipse, we have three things that we needed to keep track of. A is a distance from the center to a vertex. B is the distance from the center to a co-vertex. And C is the distance from the center to a focus.
Did you write those all out? Actually, no. Never mind.
We're gonna go to when we talk about our equation. We'll put those out. We'll write those out in a little more detail. And the importance relationship between A, B, and C. A squared equals B squared plus C squared for any ellipse. So we have a Pythagorean theorem kind of thing going on between A, B, and C. A squared equals B squared plus C squared for any ellipse. And we're going to use these quantities to write the equations of our ellipses, depending on whether their axis is vertical or horizontal. All right, any questions about our parts here? Let's talk about our standard form of our equation. And we're going to do like we did with our parabola. We're going to talk about a horizontal axis and a vertical axis. So we'll start with our horizontal axis. So major axis, that's the longer axis, that's the stretched part. So let me grab a horizontal ellipse. So there's our horizontal ellipse. For an ellipse, you should draw the ellipse, and we'll work with the. It's the same picture that we had on the other side. The only part that's missing here is this distance is c. All right, for an ellipse, a is greater than b. So a is the bigger number. A squared equals b squared plus c squared, always for an ellipse. Our equation looks like this. X minus h squared over a squared plus y minus k squared over b squared equals 1. So the thing that's going to tell us that our major axis is horizontal. The biggest number is under the x part. Sorry, b squared, thank you. So when we have a horizontal major axis, our biggest number is under the x part. Our center is the point HK. So just like we worked with a parabola, our center is HK. Rather than the vertex, this gives us our center. The major axis length is 2a. So each of these segments is a. So the entire major axis is 2a units long. The minor axis length is 2b. So this is a b here and another b here. So our minor axis length is 2b. Our foci, C tells us how far the center is from the focus. That's what the C in this equation tells us, how far the center is from the focus. So when our major axis is horizontal, our focus is going to be C units to the right and C units to the left of the center. So we're just going to move right and left from the center by C units. So our foci are going to be at H plus or minus C K. So we're just moving to the right and the left by C units from the center. The vertices. A tells us how far the vertex is from the center. So to find the vertex, I'm going to move A units to the right and A units to the left of the center. So my vertices are going to be H plus or minus A, comma K. I'm not moving up or down, I'm just moving to the right or left. The co-vertices. The co-vertices, I'm just moving up and down from the center by B units. So I'm not moving left or right. So H, K, plus or minus B. And if my center is at 0, 0, then my equation just looks like this. X over a squared plus y over b squared. Sorry, y squared over b squared equals 1. So this is an equation of an ellipse with our horizontal major axis if the biggest number is under the x, if our center is at 0, 0. So, again, the important things to remember about all of our equations here. A tells us how far the center and the vertex are apart. B tells us how far the center and the co-vertex are apart. And C tells us how far the center and the foci are apart. So questions about that? Questions about our equations? So there's a little more to keep track of with ellipses. We have this A, B, and C. All right, let's talk about our ellipses with a vertical major axis. Let me grab my picture of my vertical major axis. So it's the same picture, it's just turned sideways basically. A is still the distance from the center to the vertex. B is the distance from the center to the co-vertex. And we'll draw in C here. C is the distance from the center to the focus. We're still saying here that A is our biggest number. So A is greater than B. And A squared equals B squared plus C squared. So this is true for any ellipse. So our equation, y minus k squared over A squared plus x minus h squared over b squared equals 1. The way we tell it we have a vertical major axis is our biggest number is under the y part. So A is bigger than B. The biggest number is under our y part. So that tells us we have a vertical major axis. Our center is still at HK. And now for our focus and our vertex, we're moving up and down from our center. Because our major axis is vertical, we move up and down from our center to get to our focus and our vertex. So again, the major axis is 2a units long. Minor axis, always, is 2b units long. B to here, B to here. The foci, we're moving up and down by c units from the center. So our x doesn't change. So our foci is going to be h k plus or minus c. C tells us how far to move from the center to get to the foci. Our vertices, we're not moving left or right, just moving up and down. H, K plus or minus A. A tells us how far to move from the center to the vertices. our co-vertices. Now we're moving left and right from our center because our minor axis is horizontal. So we're going to be at h plus or minus b. Okay. So we're moving right and left from our center by b units to get to our co-vertices. And if our center is at 0, 0, my equation just turns into y squared over a squared plus x squared over b squared equals 1. A is bigger than b, and a squared equals b squared plus c squared. So those are our equations. So questions about our equations? So what I want to do next is just do a few examples working with these equations. All right. So the first example, we want to find the center the focus, the center, vertices, and focus. And we want to find both focuses, so we'll call them foci. So this is what we want to find. Our ellipse, 9x squared plus 4y squared equals 36. So there's my ellipse. So the first thing that we need to do, if we look back at our standard equation, we always have a 1. We have a y squared, an x squared, and we have a 1 on one side of the equation. So I want to get a 1 on the side of the equation without the x squareds and the y squareds. So I'm going to divide everything by 36. I always want to have a 1 on the one side of my equation. So 9 divided by 36 is what? So I'd have x squared over 4 plus 4 divided by 36, or sorry, 36 divided by 4 is 9 equals 1. So let me rearrange this. I'm going to write y squared over 9 plus x squared over 4 equals 1. That's how we wrote it before. All right, so is the biggest number under the x or the y? It's under the y. So this is going to have a vertical major axis. Since my biggest number is under y, the biggest number is a squared. A squared equals 9. So a equals 3. B squared, the smaller number, is 4. So b equals 2. And we know that a squared equals b squared plus c squared for an ellipse. So I have 9 equals 4 plus c squared. So c squared is 9 minus 4. I subtract 4 from both sides here. C squared is 5. So c equals the square root of 5. Now if I were to, it can be very helpful to draw a quick sketch of this ellipse. First off, where is the center of this ellipse? 0, 0. We're not adding anything to the x. We're not adding anything to the y. So our center, we know right away. Our center is at 0, 0. So here's my center. We know that the axis, the major axis is vertical. So it's going to be longer this way than this way. A tells us the distance from the center to the vertices. So I'm going to go up 3. So this is going to be 0, 3. And I'm going to go down 3. 0, negative 3. So my vertices are at 0, 3 and 0, negative 3. I've gone up and down 3 units from the center. Did it ask us the co-vertices? No, just the vertices. And the focus, each focus is going to be C units up and down from the center. So this is going to be 0 square root of 5 and 0 negative square root of 5 would be my 2 foci. And if we wanted to make a rough sketch of our ellipse, we know that B is 2. So to get to our minor, our co-vertices, we go over 2 units both ways, and my ellipse would look something like that. So that would be a rough sketch of my ellipse, and we figured out our center, our vertices, and our foci. We found A, B, and C, and that gave us all of our information. Questions on that example? So the key with ellipses is finding A, finding B, finding C, and remembering what that tells you about the ellipse. A, distance from the center to the vertices. B, distance from the center to the co-vertices. C, distance from the center to the foci. All right, let's look at another one. We want the equation in standard form. So we have an ellipse with a center at the origin. The major axis is length 10. And the minor, the foci are plus or minus 3 and 0. So this is telling me that we have a focus at 3, 0, and minus 3, 0. All right, so if you get a problem like this, what I suggest you do is make a little sketch. So doesn't have to be fancy. My center is at 0, 0. We have a focus at 3, 0 and a focus at minus 3, 0. Does this ellipse have a vertical or horizontal major axis? Each focus is on the major axis. If we look back at our pictures, the focus is on the major axis. The focus is on the major axis. So because my 2 foci are on the x-axis, we have to have a horizontal axis. So when we write our equation, is the big number going to be under the x part or the y part? Under the x. When our axis is horizontal, the big number is under our x. Our center is at 0, 0, so I know I'm going to have x squared over something plus y squared over something equals 1. The major axis is 10 units. So A is 5. 2A equals 10. So A equals 5. So what goes under the x? A squared, the biggest number goes under the x. So this has to be 25. Now I need to find B. Now this is A squared. So now we need to find B. We know that A is 5. Well, this information about the foci tells us about C. So what is C going to be? C is the distance from the center to the focus. So that's going to be 3 units. So if I draw on my little sketch here, that's 3 units. So C has to be 3. We know for an ellipse, A squared equals B squared plus C squared. So I have 5 squared equals B squared plus C squared is 9. I'm going to write this as 25 instead of 5 squared. 25 equals B squared plus 9. So B squared equals 16 and B equals 4. And B squared goes under this part. So that would be 16. So this is our equation. X squared over 25 plus y squared over 16 equals 1. The information about the major axis gave us A. The information about the focus gave us C. And we know that A squared equals B squared plus C squared. So we were able to figure out B. And because our focus was to the right and left of the center, we knew that our axis had to be horizontal. Questions on that one? All right, we're going to do one more example. So we want to sketch the graph. Of 25 x squared plus 9y squared minus 200x plus 36y plus 211 equals 0. So when we have a problem like this, anybody want to make a guess what we have to do here? We have an x squared and x. We have to complete the square twice. Once for x and once for y. So a problem like this means we have to complete the square.
Does that say plus 211?
Plus 211, yes. You have to complete the square twice. So what we're going to do is group the x terms together. So I'm going to write 25 x squared minus 200x. Group the y terms together. Plus 9y squared plus 36y. I'm going to put the number by itself on the other side. So I'm going to subtract 211. Equals minus 211. Now I'm going to complete the square on the x part and on the y part separately. So the first thing that I want to do here is factor out this 25. So I'm going to write this as 25 times x squared minus 200 divided by 25 is 8. I'm going to factor out this 9. 9y squared plus 4y equals minus 211. Now we complete the square on the x part. 25 times x squared. B is negative 8. b over 2 would be negative 4. Negative 4 squared is 16. Now here's where we have to be careful. The 25 is multiplying the entire parentheses. I'm not just adding 25, I'm adding 25 times 16 here. So I'm going to go over here, and this equals minus 211. 25 times 16 is 400. So I'm adding 400 to the other side. So I could subtract 400 here, instead I'm adding 400 here. So I'm adding 400 here, adding 400 there.
Wouldn't you subtract on the other side then, if you're adding on this side?
So we add the same thing to both sides.
Oh,
You're thinking if we keep it all on the same side, I add and then subtract. So I end up with 0. But if I'm adding to one side, I can add to the other side.
okay.
Okay? I'm going to do the same thing here. 9 times y squared. B is 4. B over 2 is 4 divided by 2 is 2. And 2 squared is 4. And here, I have to remember I'm multiplying 9 times 4. So I'm adding 36 here. So I add 36 to that side. Add the same thing to both sides. So now I get 25. This is a perfect square. X minus 4 squared plus 9 times y plus 2 squared. If I add all these together, I get 225. My equation for an ellipse has a 1 on this side. So I'm going to divide everything by 225. When I divide that out, 225 divided by 25 is 9. X minus 4 squared over 9 plus y plus 2 squared over 25 equals 1. All right, so there's our standard equation. And from this we could sketch a graph. So is this going to have a major axis, vertical or horizontal? Where's the biggest number? Vertical, because the biggest number is under the y part. So we have a vertical axis. So we know our graph is going to go up and down. Where's our center? Not at 0, 0.
It's at negative 2, 4.
The x part tells us the x coordinate.
Oh.
So it'd be 4, negative 2. This tells us the x coordinate, we change the sign. This tells us the y coordinate, we change the sign. So our center is going to be at 4, negative 2. So I'm just going to make a really rough sketch. From this, A equals what? 5. This is a squared. And this is b squared. So a equals 5. And b equals 3. So I go up and down 5 units from 4, negative 2. So if I go up 5 units, I would be at the point 4, 3. If I go down, and this is 4, negative 2. If I go down 5 units, I would be at 4, negative 7. Move left and right by 3 units to find my minor axis. So if I move left by 3 units, I would be at 1, negative 2. And if I move right by 3 units, I would be at 7, negative 2. So there would be a rough sketch of my ellipse. Not a great sketch, but you get the idea. A tells us how far to the left and how far up and down from the center to move because our major axis is vertical. B tells us how far left and right from the center to move to get to our co-vertices. And then we can sketch a graph from there. Questions on that example? All right, homework. There you go. The questions on our quiz will be similar to ones we just did as our examples, similar to what we did with the examples we did with parabolas on the board today, the homework problem, and then the limits are also on that quiz. So the way to prepare for the quiz, look over the limits packet and look over your homework.